Okay, kind of nightmarish numbers. It's 100,000, and then it increases in 5 years' time to 161,051. All right. So I hope you realize that at the beginning of time, exactly 1 year later, the population has grown by a certain rate. So if you were to write that down, it's going to be 100,000, and certainly the population is there, plus there's a rate of growth to it. And that's going to be how many at the end of the first year. Now, the second year, you're going to do another multiple of this. So it's 1 plus r. And then the third year, another multiple of this. The fourth year, another multiple of this. The fifth year, another multiple of this. And that's at the end of the fifth year. Now, certainly what's going to happen over there, if you did that, you'd get this number in the population. That's the growth rate. So how would you write down, again, nightmarish numbers, but 161,051 equals 100,000. I put comma over here. And it's probably a little bit easier to write down 1 plus r to the fifth power. All right? Now, someone says, how could you solve that for r? I think I would use a calculator, but you get 161,051 over 100,000. I have a tough time counting those zeros, equals 1 plus r to the fifth power. By the way, r is a positive number. I'm going to take the fifth root of both sides. Yeah, I'd use a calculator for that. In Wells' day, they didn't have a calculator. Actually, they did, but they were called human calculators. They were actually people who could do arithmetic very quickly. They had to resort to tables to look up any difficult multiplication, like fifth root problems. And the tables are based on logs, which are very difficult to do arithmetic, in my opinion. And the main reason is we have calculators. This is 1 plus r. So what's r going to be equal to? It's going to be the fifth root of 161,051 over 100,000 minus 1. By the way, I used a calculator, and there's no doubt about it. By the way, calculators are quite good. I mean, they really are. You get a nice, easy number on it, and you get, it's actually, the r turns out to be 0.1. And the yearly growth rate, I want to point out 1 means 1/10. So if you do this computation over here on a calculator, your calculator should say 0.1, if not exactly 1/10. A modern calculator typically does exact arithmetic, by the way. By the way, that's if you're typing it incorrectly. I realize sometimes my penmanship is hard to read, but that's a 6 over here. All right? So the question is, what is the rate of increase per year? Well, it's going to be 1 plus that number. And 1 plus r, and r is 1/10, would be 11/10. Thank you.